Hello everyone, this is Manyepa, and today I'm going to look at the atom. There are quite a number of definitions that are about the atom, and one of them is that atoms are basic units of matter. That definition is correct but not so correct, and we're going to see the reason why. I have two definitions there, and the first one reads, an atom is the smallest part of an element that can take part in a chemical reaction. The second one reads, an atom is the smallest part of an element that cannot be split into any simpler form by any chemical means, meaning that an atom can be split physically if you have the means, but you cannot split it chemically. Therefore, there is no chemical reaction that can split an atom into its constituent parts or particles. All matter is made of tiny particles called atoms. It is these atoms that are grouped into groups called elements based on their atomic numbers, which determine their chemical behavior, in brackets chemical properties. If not composed of atoms, matter is made up of either molecules or ions. This is the reason, or this statement gives us the reason why I said my first definition, which states an atom is a basic unit of matter, is not so correct. Okay, because atoms can exist as molecules, therefore in bundles or groups called molecules, or as charged particles called ions. A molecule is a stable group of atoms. Some molecules are heteronuclear, meaning having different nuclei, meaning two different atoms. A molecule made of two different types of atoms. I have an example here of carbon dioxide, composed of two types of atoms, oxygen and carbon, and altogether in this molecule there are three atoms. This is an example of a triatomic molecule. One carbon, two oxygens, and homonuclear. Therefore, some molecules are actually made of the same type of atoms bonding with each other. An example there is nitrogen, composed of a molecule for nitrogen composed of two atoms of nitrogen. An ion is a charged particle which can be a charged molecule or a charged atom. Therefore, a charged molecule, an example is here where we have the sulfate ion. Sorry, there I'm supposed to have a 2 minus. Therefore, 1 sulfur, 4 oxygen, then a 2 minus up here. I put a single minus, supposed to be a 2 minus. Or a charged atom like potassium with a single plus there. So, an ion is a charged particle which can either be a molecule, therefore a charged molecule, or a charged atom. Atoms are composed of three types of particles called subatomic particles. The word sub means under. Therefore, the atom is very small, but below the atom are other smaller particles or components that make up the atom. These are protons, neutrons, and electrons. Protons and neutrons are called nucleons because they make up the nucleus. Electrons orbit the nucleus in electron clouds called orbitals or shells. Coming back to nucleons, nucleons give the mass its atom. Therefore, the number of protons tells you the number of protons put together with the number of neutrons tells you the mass of an atom, because protons and neutrons are quite heavy. Look at this table here. The mass of one proton is 1 AMU, which is 1 atomic mass unit, a unit which gives an atom its mass. Also here, neutrons 1 AMU, and when it comes to the mass of electrons, the mass is quite very small, so it's usually negligible. Coming to this point here, electrons orbit the nucleus in electron clouds called orbitals or shells. These shells are simply, or an orbital is a region or space around an atom where there is high probability of finding electrons. Electrons are always in motion. Therefore, these spaces are actually mathematically calculated spaces where you are likely to find electrons around the nucleus of an atom. Coming back to the table again, protons have a positive charge, neutrons no charge, that's why they're called neutrons, and then electrons have a negative charge. The symbol for a proton is P, sometimes it's given Z, but it's P. Neutrons N, then electrons E with the negative there, which could also be placed on top there. Protons and neutrons give an atom its mass. Therefore, they are atomic mass units, AMU. Electrons or electron mass is negligible. The proton number is the number of protons. The symbol is Z. The symbol given to the proton number is Z. The nucleon number is atomic The nucleon number is the atomic mass. Therefore, the nucleon number is the number of protons and neutrons put together. Its symbol is A. So when you add protons and neutrons, you get the atomic mass. Adding protons and neutrons gives you the atomic mass. Moving on to the next slide. That's the figure or a picture trying to show an atom. Here it's appearing like the solar system or something like that, but it's not really like this. These orbitals, these lines here represent the shells. This atom has got 3 shells. Okay, it has got 3 shells, and I can tell its atomic number by counting the number of electrons, because I'll take the atom to be neutral. The first shell has got 2, the second shell has 8, then the other one has 1. So 8 plus 3, that's about 11, which is almost 11. That's the atomic number for potassium. 11 is the atomic number for potassium. Am I correct? Hopefully I'm correct. So this is our nucleus, and those are our electron shells or orbitals. Elements. An element is a pure substance composed of the same type of atom. Elements are represented by nuclides, just like in your periodic table. Pick up a periodic table, and what you're going to see there are nuclides. A nuclide shows the mass, which is the atomic mass, the atomic number, and the chemical formula of the element. Note that the symbol represents note that the symbol representing an element is used to represent an atom or atoms belonging to that element. And going to the next slide, there is a chart showing some elements there and their symbols. We have aluminium on top there, copper, the symbol Cu, which actually means cupric, iron, the symbol is Fe, which means ferrous, lead, the symbol is Pb, which means plumbum, then magnesium, then mercury, then potassium. So as you can see, some symbols of some elements are actually the symbols or initials or some letters from their Latin names. Then these may differ, so the names may differ. Some elements may have their English names or English names, allow me to say English names, and they may also have their Latin names. So you may find that some names are preserved, like this one, plumbum is simply an old name for lead, which comes from all the way from Latin and ancient languages, but right now we call it lead. So the name is preserved through the symbol of the element. This symbol also represents 1 atom of lead. So the list goes on here to bromine, carbon, chlorine, hydrogen, and the list goes on and on up to the whole of the periodic table. Isotopes. These are atoms of the same elements having the same atomic number but different nucleon numbers, therefore different mass. So if there's the same atomic number, remember, atomic number is the number of protons, and they have different mass numbers. This means that they have the same number of protons but different number of neutrons. So earlier on we said elements are simply arranged according to their atomic numbers, or atoms in an element have the same atomic numbers. They have the same number of protons. So it doesn't matter how many neutrons they have. If they all have the same number of protons, they have the same chemical properties. Therefore, they'll be referred to as the same element. But the fact that they differ in the number of neutrons, they are given this term as isotopes of the same element. I have an example here of 3 isotopes of hydrogen. There is hydrogen 1, hydrogen 2, and hydrogen 3. Remember, an isotope is also, or is actually called by its mass for the sake of differentiation, because they differ in the nucleon number. But you can also call them by their special names, like here we've got hydrogen, we've got deuterium, then we've got tritium. Hydrogen, deuterium, tritium. But again, you can say hydrogen 1, hydrogen 2, hydrogen 3. Some few elements on the periodic table, or let me just say quite a number, do not have multiple isotopes. Therefore, they only have one type of atom. And so that one type of atom is still called an isotope, a single isotope. But here, these are 3 isotopes. We move to the next slide. Isotopes are called by their masses, therefore hydrogen 1, hydrogen 2, and hydrogen 3. There are small physical differences between isotopes. For example, the heavier isotopes has a greater density or boiling point. Therefore, having more neutrons does not affect the chemical properties of an isotope, but it affects all the physical properties. All the physical properties. However, because they have the same number of protons, they have the same electronic structure and identical identical chemically. This I've already spoken of it. The fact that they have the same number of protons means they'll be identical chemically, therefore they'll be termed as belonging to one element. Lastly, there is a nuclide of lithium showing the mass number there. Okay, the nucleon number or mass number, then the proton number. So in this number there are 3 protons and 4 neutrons. But again, this 3 here is specifying the number of protons. In a neutral atom, the number of protons is equal to the number of electrons. In a neutral atom, the number of protons is equal to the number of electrons. So nuclear notation of isotopes is what this small chart is all about, which may represent any other element on the periodic table. Basically, that's what I had for you today. Hopefully it was helpful. Remember to leave your comments and subscribe for more videos. Thank you.